is working to establish a sigma score for each analyte on the chemistry analyzer. What does a sigma score of 5 imply for the analysis? Please select the best single answer. 1. There is a lower risk for producing unreliable results. 2. There is a higher risk for producing unreliable results. 3. Requires 1 level of quality control and 1 to 2 control rules. 4. Requires frequent QC intervals with several multi-rules. Feedback. The sigma metric typically ranges from 0 to 6. The larger the sigma metric, the less chance there is for a serious error with the assay. The smaller the sigma metric, the more problematic the assay and the greater the risk of producing unreliable results. An assay with a sigma metric between 4 and 6 would require 2 levels of controls and 1 to 2 control rules, while an assay with a sigma metric of less than 3 would require frequent QC intervals with several multi-rules. Therefore, a score of 5 would imply a large sigma metric with a lower risk for serious error. The requirement for QC would be 2 levels of controls evaluated once/day with 1 to 2 control rules for evaluation. A lower sigma score is a higher risk for serious error and would require frequent QC intervals with several multi-rules. The following chart shows appropriate sigma scores, QC frequency and number of samples, and appropriate QC rules. A new lot of quality control is being implemented for all chemistry analytes. Ranges for each control are being established. The mean of the calcium control, as per the manufacturer, is 9.4 milligrams per deciliter. The standard deviation is 0.5 milligrams per deciliter. Considering a range including 95% of the values, which of the following would be an appropriate range for this quality control material? Please select the best single answer. A. 8.4 to 10.4 mg/dl. B. 8.9 to 9.9 mg/dl. C. 9.2 to 9.6 mg/dl. D. 7.9 10.9 milligrams per deciliter. Feedback. Establishing the range for each control incorporates using the mean as a central value. The range is then established by incorporating the multiples of the SD, e.g., plus or minus 2 SD. Using the mean as the central value, the upper and lower level of the range is set with plus or minus the chosen multiple of the standard deviation. For a range of 95%, the values are plus 2 SD. In this case, the mean for calcium control is 9.4 milligrams per deciliter. The SD is 0.5 milligrams per deciliter. 2 SD equals 1 milligram per deciliter. 1 milligrams per deciliter on each side of the mean of 9.4 is the range. The range is 8.4 to 10.4. 8.9 to 9.9 mg/dl represents plus 1 SD, 0.5 milligrams per deciliter, on either side of the mean. 7.9 to 10.9 mg/dl represents plus 3 SD, 0.5 milligrams per deciliter, on either side of the mean. 9.2 to 9.6 mg/dl would be an estimate of 1/2 SD, 0.5 milligrams per deciliter, on either side of the mean. The true values would be 9.25 to 9.65 mg/dl. Since the range utilizes 1 decimal point, the second digit would not be included. On the weekly QC review, the graph at the right was noted on one analyte. This graph is referred to the laboratory manager for review as the technologist was uncertain if there was a rule violation. Which of the following is the correct interpretation of this graph? Please select the best single answer. 1 yes, 2 rule violations, 1 resulting from a random error and 1 resulting from a systemic error. 2 yes, 1 rule violation resulting from a systemic error. 3 yes, 1 rule violation resulting from a random error. For no, there were no rule violations. Feedback.
Feedback. Yes, there was 1 rule violation resulting from a random error. The rule violation is 1-3S, which is attributed to a random error. Weekly QC data review must include a review of the control data and the application of appropriate rules for all controls. Rules assessing imprecision, such as 1-3S and/or force failures, are usually associated with random error. Rules assessing consecutive control observations, such as 2-2S, 4-1S, and 10X, are usually associated with the systematic error.
A technologist working alone is unsure of the low analyte value obtained on a single proficiency testing sample. The result was outside of the normal range, but not within the range of critical. Repeat testing is to be performed only for critical values. The technologist considers calling a fellow technologist at another local hospital to confirm the results and forwarding the sample to that laboratory for confirmation. Which of the following statements are correct? Please select the best single answer. 1. Calling personnel at a different facility to confirm the result is acceptable since the testing technologist is working alone. 2. Repeating the sample prior to calling the technologist at the other facility would have been the correct approach. 3. Calling another laboratory to compare results is permitted as a corrective action step. 4. Forwarding the sample to another laboratory for confirmation is not permitted. Feedback. Referral or forwarding of PT samples to another laboratory is not permitted. PT samples should never be sent out of the laboratory for any reason, even if patient specimens are routinely sent out for additional or confirmatory testing. Personnel in one laboratory are not permitted to communicate with those in another laboratory regarding PT samples until after the test results are submitted to the PT provider, and the deadline for submission of